Hi guys and welcome to this, the Year 9 Numeracy Calculator Aloud NAPLAN solutions. Hopefully you're going to find these useful. I'm going to work through these question by question, giving you what I think the right answers are. Hopefully I won't make any mistakes, and theory behind it if needs be. Hopefully you are ready to go. I'm just going to load up my calculator. Just bear with me a moment so that I can use it when needs be. Okay, Brian made this 3D shape object when using 48 small cubes. Which of these has a volume half of that of Brian's object? So looking at this shape here, let's have a look at what the volume could be. Rightio, because Brian makes the 3D object using 48 small cubes. They told me it was 48 small cubes. We want the volume half that of Brian objects. So we are looking for a volume with 24 cubes. Something with 24 cubes. It's obviously not this one here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not that one there. So let's see, 24, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It is actually this one here. So as far as I'm concerned, that's just count. Let's just check this one. 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There we go, it's that one there. So that's just counting. Calculator, not really. Which of these can be measured in litres? Now, litres is basically a capacity. So we're looking for things that like sort of three-dimensional in shape, not length, not mass, because that's not area. It is in fact volume. It can be measured in litres, or more specifically capacity, funnily enough. This is Donna's left shoe. Donna's right shoe is a mirror image of her left shoe. Now by a mirror image, it means it looks like it's been in a mirror. Which of these is Donna's right shoe? Well, what I notice here is if I was going to turn that shoe around the right way, he says talking that way, then I've got a section that seems to do that. All right, so this section here seems to do that. So my mirror image would look like it's going to do that. So it can't be this and it can't be this. So it's either this shoe or this shoe here. So now I've got to try and find some other distinguishing feature of what makes it different. And as it turns out, it appears that this black section goes all the way from side to side. This one here seems to be missing. So I'm actually going to go with this shape here. Hopefully that's just not just a really stupidly bad drawing. Let's just check. 1, 2, 3, 4, 5, 6 laces. 1, 2, 3, 4, 5, 6. Yeah. So I actually think that first answer is the correct one. Y is equal to 2x squared minus 8. What is the value of y when x equals 2? This is a substitution question. So we're going to do y is equal to 2 times x squared, which is 2.2 squared minus 8. Now obviously putting this into your calculator is going to make all the difference. So 2 times, and open brackets, 2.2 squared. I know you can't see in my calculator, but I'm talking through the process so that you do it right, all right? So I actually put the brackets in my calculator just to make sure that I don't make any silly mistakes, and out came the value of 1.68. The speed of sound at sea level is 340 meters per second. What is the speed of sound in meters per minute? Okay, so if it's per second, 340 meters per second, and I want to get it meters per minute. How do I do that? Well, if it covers 340 meters in a second, then 340 times by 60, because there's 60 seconds in a minute, 340 times by 60 gives me 20400. Right, so that's a conversion question. What is the value of this rounded to one decimal place? Again, I'm firing up my calculator. 63.4 plus 28.24, just adding those in. And the great thing about my calculator is I can put it actually in a fraction form. But again, let's just check. We get 6 point, and it wanted it to one decimal place, so 6.2 is the correct answer. Ideally in this situation, if you don't have a special calculator, do 63.4, add 28.24, right equals, hit equals on the calculator and work out what that is. So 63.4 plus 28.24, I think it is, gives me 91. So if I was doing this, I'd write in the margin 91.64. Then I would work out the bottom, which is 9.2 times 1.6. And again, write that in the bottom, 14.72. And then I would make sure that I did 91.64, divided by 14.72. I split that up into 3 calculations. Work out the value on the top, work out the value on the bottom. Because if you use your calculator wrong here, sadly, you're going to get the wrong answer. Okay, so with this question here, we are looking at a cardboard box is the shape of a cube. Now, obviously, we know with the cube, the length here, the length here, and the length here are identical. It's filled with identical small cubes of the size shown. Okay, so then what it says is, well, roughly speaking, how many small cubes will the large cube be filled with? Now, how I did this was I used a bit of paper, and I'm doing it now, actually, funny enough. I'm using a little bit of paper, and I'm roughly marking off one cube. And then what I'm doing, he says, moving the screen around, is trying to work out how many small cubes would fit in to my large cube. Sorry while my screen moves, because this isn't actually as helpful or as easy as I thought it was going to be. So there's 1, he says, bear with me, 2, 3, 4. Well, there's the good one. So actually, roughly speaking, I reckon I'm going to get 4 cubes across. Now, if that's the case, I'm going to get 4 cubes by 4 cubes. I get 4 cubes that way, 4 cubes that way, and 4 cubes that way. So when I do that, 4 times 4 is 16. Times that by 4 gives me 32, which gives me 64. And so the closest value of that is 40. Now again, if you think it's 5, then you would be doing 5 times 5 times 5, which is 25 times 5, or 125, in which case that would be your closest answer. I'll probably check that one later on just to come back and make sure that we get the right answer. 1 billion is 1,000 million. Well, it is if you're an American. Which of the following is 70 billion? So we want 70,000 million. All right, so 70,000 million. Now, standard form is a way of writing numbers in a special way. And these basically are examples of standard form. Just going to rub those out so as not to confuse. Now, how do we write a number in standard form? We're trying to turn around and say 7 times 10 to the floaty what number will give me that one above. And if you remember, 10 times 10, which is 10 squared, is 100. 10 times 10 times 10 is 10 cubed. So basically the number of zeros we have is effectively the floaty number. Now that's a shortcut. The rules change. But so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are looking for 7 times 10 to the 10, which would give me that value there. There are 12 apples and 7 pears in a bowl. About what percentage of the fruit in the bowl is pears? Okay, so we've got 7 pears out of a total of 19. Now that's a fraction. To turn it into a percentage, we do 7 divided by 19, which gives me a decimal. And then I would times my final answer by 100. So 7 divided by 19, hit equals, times that by 100, gives me that value there, which on my calculator isn't very helpful because I want it as a decimal. So roughly speaking, 36.84%. So we want it, you know, about what percentage? Something close to that. And so 37% is my correct answer. Which one of these has the same value as 20 squared? Again, 20 squared is the same as 20 times 20. Now again, there's lots of ways of doing this. You could put each of these in your calculator and work it out. And to be honest with you, that's probably what I would do. 20 times 20 is 400. We're looking for something that's the same as 400. Well, I already know it can't be that one because 2 times 10 is 20 and 20 times 10 is 200. That's no good. 4 times 5 squared is 4 times 5 times 5. Well, 4 times 5 is 20, times 5 is only 100. It's not going to be that one. 40 squared is 1600, right? Now, how do I know that? Because it's 40 times 40, which when I divide that by 4, will actually give me, well, there we go, believe it or not, 400. That there is the correct answer. We could also have checked this one here, because we know that 2 times 2 is 4, 5 times 2 is 10, times by 5, 10 times 5 is 50, 4 times 50 is 200. That is not my right answer. So there we go. So again, lots of ways of doing it. You can do it on your calculator if you want to check. A concert starts at 10:28 a.m. and runs for 124 minutes. Well, 124 minutes is 2 hours and 4 minutes. I hope 124, yeah, 2 hours and 4 minutes. So what time does it finish? We're going to add on 2 hours to 10 a.m., which is going to give me 12 p.m. And then 28 and 4 is going to give me 32. So 12:32 p.m. Ka-ching. Notice they gave you the AM and PM thing. That was obviously just checking to see if you can know the difference. The diagram shows an isosceles triangle. What does an isosceles triangle mean? It means that the two sides are exactly the same length. What is the size of angle? Now, again, this slush, boop, 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 that there says angle, and it says starting at A through B to C. So again, being able to show what that angle looks like, start at A, head to B, and end up at C. Hopefully you realize it is this angle here. Well, what we know about an isosceles triangle is that once we know this angle here, which is 77, angles in the triangle add up to 180 degrees. And we know, because those two little lines basically point arrows to say, we're the same, we're the same, we're the same. So we know that this angle here and this angle here are the same. So I'm going to do 180 minus 77 to tell me what angles are left. So there are 103 degrees split now between those, and they are the same size. So if I now divide that by 2 on my calculator, I get the wonderful value of 51.5 degrees. So there we go. So 51.5 degrees is my correct answer. The petrol gauge in Lynn's car showed that she had used half of the petrol in the tank. All right, so she'd used half the petrol. She then spent $42 filling up her tank at a cost of $1.35 per litre. Approximately how much petrol can Lynn's petrol tank hold when it is full? Approximately how much petrol can Lynn's petrol tank hold when it's full? So she's basically taken $42 at $1.35 per litre. We need to work out how many litres can go in a tank. Now, bearing in mind, it says her tank was half full. So if I spent $42, if I do 42 divided by 1.35, then I know, roughly speaking, that half a tank has 30 litres, okay? So if that's half a tank is 30 litres, then roughly speaking, my whole tank is going to be approximately 62 litres. So this question, Tegan and Caleb collected money for charity every month. If Caleb had collected $10 more, so Caleb, if he collected $10 more, he would have collected exactly twice as much as Tegan. That's equal to twice as much as Tegan. Which of the rows show how much money they could have collected? So we're going to take Caleb and add 10. So if Caleb did 30, then that would have meant that Caleb plus 10, 40, would have been twice as much as Tegan, or Tegan would have done $20. That's not my right answer. So Caleb has got $50. Add the $10, which gives me $60. Now that would have been twice as much as Tegan, $30. It's not that one there. So now 40, we're going to add on the $10, which is $50. Divide that by 2, which gives me that answer there as $25. We'll just check the last one. 80 plus 10 is 90. Divide that by 2 gives me 45, and it's not that one there. So again, trial and error, actually having a go at these. How many more cars were produced in North and South America than in Europe and Africa? So what they're asking you to do is add together the number of cars in North and South America, add together the number of cars in Europe and Africa, and then take them away, because it wants how many more cars. So let's see what we got. We've got North America, which was 21136,313. We're going to add that to South America, which was 4288654. Hit enter, and I'm going to write that value down, 254,24967. That's a lot of cars. Yep, okay. So what are we going to do now? We're going to add Europe and Africa together. So 197,26405, and we're going to add on Africa to that of 636,519. Gives me 20362924, and I'm going to subtract those away from each other. And what am I going to get? 5062043. Mia drew a shape. It only had one pair of parallel sides and only one internal reflex angle. Oh, what on earth is a reflex angle? Reflex angle, as far as I'm concerned, is one that goes bigger than 180 degrees, but less than 360. So let's see, we've got two parallel sides. Well, one pair of parallel sides. These lines here are parallel. Okay, but these lines here are parallel, so it can't be that shape there. They are parallel because they're never going to meet. What about this one here? This side here and this side here is parallel. Okay, this is parallel and that is parallel. and then basically none of the sides on this shape are in fact parallel, so it can't be that one. So it's between these two one, and it's got a reflex angle. Well, this angle here is less than 180 degrees, this angle here, and this angle here, and all of these angles in fact are less than 180 degrees, so it can't be that shape there. This angle here has one internal reflex angle, so that one angle more than 180 degrees, so it's got to be this angle here. Remember, parallel lines will never ever meet, and the trick here was this line here and this line here in fact are parallel because they're never going to meet. Simon is facing west, so let's do my never eat soggy Weetabix or Weet-Bix. Simon is facing west. He turns 135 degrees clockwise, so he's going to turn 135 degrees clockwise. That's 90. All right, so Simon is facing west. He turns 135 clockwise. Simon then turns anti-clockwise until he faces east. By how many degrees did he turn anti-clockwise? So he's going to go 135 degrees there, plus 90 degrees there, and plus another 90 degrees there to get him to be facing east. So I'm going to do 135 plus 90, which gives me 315 degrees. The equation 2y plus 1 equals x is rearranged to have y as the subject. Now, when it says as the subject, it wants the equation to be y equals. And for those of you who have me today, we've been doing a lot of this. So if we've got 2y plus 1 equals x, first thing I'm going to do is I don't split up the kissing couple, so I leave the 2 and y together, and I'm in fact going to subtract 1 from both sides. What is that going to give me? 2y on its own is equal to x minus 1. Now we're going to split up the kissing couple, and what's between the two of them? Yep, a times by 2. So I'm now going to divide both sides by 2, and that's going to give me that y is equal to x minus 1 all divided by 2. Have we got that one there? We do indeed. It's that first one there. Which of the following has the same value as 13 to the power of minus 13? Now, my teacher, Mrs. Hurst, always taught me that a negative floating number meant that you switch it, and that is exactly the same as 1 on 13 to the floaty 13. So this minus sign turns into a 1 over, and then you write the number as if it didn't have the floaty negative number. So let's see, did we have that one there? We do indeed. That's question there. Now, some of this you may have done, some of this you might not have done. The rule for calculating the price to deliver a parcel of mass m kilos is given by that. So that says the price is equal to 7 plus 3.5 times m. All right, so what is the mass in kilos of a parcel with a delivery price of $70? So what they're now saying is, here we go, we're now the price. So we know 70 is equal to 7 plus 3.5 m. What we're going to do, well, again, keep the kissing couple together. So there's a times between them that gets done last. And I'm in fact going to move the 7 by taking 7 away from both sides. 70 minus 7 gives me 63. So 63 is equal to 3.5 m. What's between the 3.5 and the m? There is a time. So 63 is equal to 3.5 multiplied by m. Again, I split them up. How do I get rid of times by 3.5? I'm going to divide both sides by 3.5. So doing that on my calculator gives me the value of 18. So there we go, my parcel must weigh 18 kilos. David drew this diagram of a frog's skeleton. Gross, the actual length of the frog's body is 100 millimeters. What is the actual width of the frog's head? Right, okay, so the actual length of the frog's body is 100 millimeters. So what they're saying is that this number of squares on my graph stands for 100. All right, so 100 millimeters. So I now say how many big squares we've got? 1, 2, 3, 4, 5. So that means that each one of those big squares, and there's 5 of them, is 100 divided by 5, which equals 20 millimeters. So those big squares stand for 20 millimeters. And what I now can do then is say that if big square stands for 20 millimeters, and I can divide that by 1, 2, 3, 4, 5 little squares, that gives me each little square stands for 4 millimeters. Yeah, so again, a big square stands for 20, And because I've got 5 little squares, 1, 2, 3, 4, 5 little squares in the big square, I can do 20 divided by 5, and that gives me 4 millimeters. How is that helpful to me? Because I can now work out how many squares the width of his head is. So let's see if we can count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's actually not easy. So is there an easier way of doing this? He says we can go and measure off here. And we know that's 3 squares up from the bottom here. So again, maybe it's easier to count the squares now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so it's 10 squares. So 10 times 4 gives me 40 millimeters. Is that one of my answers? We don't know, but fingers crossed. If you count them as 10, just going to check that again, guys, just to make sure that I am in fact counting these off properly. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so 40 millimeters. The sand timer contains 595 grams of sand. It takes half an hour for all the sand to flow through the timer. Each milliliter of sand weighs 1.6 gram. How many milliliters of sand flow through the time per minute? Wow. Each milliliter of sand weighs 1.6 grams. It takes half an hour for all the sand to flow through. So first thing we're going to do is 595 grams. I'm going to divide that by 30 minutes to find out how many grams go through per minute. 595 divided by 30 gives me 19.83 reoccurring. Okay, now again, that's important to me for the moment. I'm not going to change that value. That's how much sand flows through per minute, and that's in grams. I know that each 1.6 grams is equal to 1 milliliter. So I'm now going to do 19.83 divided by 1.6. So I'm now going to divide that by 1.6, and I'm going to use all the answer it gives me. And it says, roughly speaking, the answer came up there as 12.39583 reoccurring. Well, let's look at what number it's closest to, and that seems to be closer to 12.4. 23, Sarah was collecting money for charity. By Sunday night, she had collected 55% of her target amount. On Monday, she collected another $70, which meant she had now collected 75% of her target amount. What was Sarah's target amount? So she's gone from 50% to 75%. So if we take those away, 75 minus 55 gives me, that's 20%. So that means that $70 was equal to 20% of her amount. What would the whole amount be? Well, $100. And so we're trying to say, well, if 20% is 70, what would 100% be? So if I do 70 times 5, I'm going to get $100. Try that one again. No, I'm going to do 70 times 5. I did the wrong thing on my calculator, which is going to give me $350. All right, so 20% is the same as $70. 100%, if I times that by 5, I'm going to times that by 5, which gives me $350, which is 100% of her target. Kim uses sticks to make a pattern of squares. Number of squares. When a shape consists of 28 squares, how many sticks will the shape have? Okay, so we're looking for a pattern. So what I'm going to do here is look at my pattern. So we've got 1 square, 4 sticks. Yeah, when we've got 3 squares, as we do here, then we've got 10 sticks. So you've got the original 4, and we're adding on, what is it? 1, 2, 3, 4, 5, and 6. This one here, so we've added on 6. Here, we've gone from this square, so we've got 1, 2, 3, 4, 5, 6 squares. So we've added on 3. And yet the number of the number of sticks we've added on 8. Here, we added on 2 and added on 6. Here, we've added on 4. And what do we notice here? We've added on 10. Here we've added on 5 squares, and here we've added on 12. So if we now look, there is a pattern. +1, so add 2, add 3, add 4, add 5, add 6, add 8, add 10, add 12. So that shows me that I can get to my next number. So I'm now going to add on 6 to give me 21, and I'm going to add on 14 to give me 54. What I'm going to add on now, I'm going to add on 7 to give me 28. and then I'm going to add on 16 here to give me 50, 60, and 70, 54, 64, 70 matchsticks. Cool, that question was quite tricky, really. Again, I had to sit and think about that one for a moment. The total length of all the edges of a cube is 156 centimeters. What is the volume of the cube? Okay, so it wants the volume of the cube. So what the first thing is, you've got to work out how many edges of a cube are there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and there are 12 edges. So there are 12 edges on a cube. Oh, edges. We know that there are 156 centimeters in total. So if I divide that by 12, 156 divided by 12 gives me that each length is 13 centimeters. So we now know that's 13, 13, and 13. And because it wants the volume of the cube, I'm now going to do 13 times 13 times 13. So 13 times 13 times 13, which gives me 2197 centimeters cubed. Which statement is always true? The opposite angles of a kite are equal in size. That is not true. Okay, so if we look at a kite, these angles here are definitely the same size, generally speaking, but those two there are not. So that's rubbish. The opposite sides of a trapezium are equal in length. Again, completely rubbish. Okay, because some trapeziums can actually look like that. Are they equal in size? The opposite sides of a trapezium are equal in length. That is also rubbish. What's the next one? The diagonals of a parallelogram are equal in length. So if I draw a parallelogram and I look at the diagonals, there is my diagonals. Are they equal in length? Very good question. The angles formed by the intersection of the diagonals of a rhombus are equal in size. So there is a rhombus. There are the diagonals. It says the angles formed by the intersection of a diagonal of rhombus are equal in size. I'm fairly sure that they are all 90 degrees for a rhombus. I think that's a perpendicular bisector. I don't think for a parallelogram the diagonals are equal in length, but could very well be wrong there. So I'm going to go for that one there, and again check in a moment. A new power drill was on sale with 15% discount. As a regular customer, Peter received a further 10% on the already discounted price. What was the overall percentage discount Peter received? Now, in these type of questions, I actually have to do the working out, and I pretend how much the drill is. So what I tend to do is I tend to say, well, let's imagine it costs 50 bucks. All right, I got 15% discount. So I'm going to times that by 0.85. Then I'm going to get a further discount, which is 0.9. And again, if you have got me as a maths teacher, you won't really know what you're doing here. So 0.85 times 0.9 gives me 0.765. So actually, we would, in that situation, multiply by 0.765, which is the same as a 23.5% discount. So 23.5%. The edges of Greg's swimming pool form a 10 by 4 meter rectangle. He tiled around the edge of the pool using one row of 400 mil by 400 mil tiles. He's tiled around one edge of his pool with 400 millimeters by 400 millimeters tiles. Greg puts one star tile at each corner of the pool as shown. He used an equal number of black and white tiles to finish off the edges. The table shows the price of each kind of tile. What was the total cost of the tiles he used? Whoa up! Right, first things first. They've done it deliberately as 400 millimeters, so that's 40 centimeters by 40 centimeters. But again, if we notice, they've actually given me units in meters. So that's 0.4 meters by 0.4 meters. He used an equal number of black and white tiles. One row, Drake put one style tile, great. Okay. Use an equal number of black and white tiles to finish off the edges. Okay. Whew, here we go. So what we now know is we've got 0.4 meters by 0.4 meters. That means we're trying to work out how many 0.4s go along there. So for that one there, I'm going to do 10 divided by 0.4. So 10 divided by 0.4 gives me 25 tiles. So there's going to be 25 tiles along there. Here I'm now going to do 4 divided by 0.4. I want to try and find out how many tiles I can fit there. So 4 divided by 0.4 gives me 10. There we go. So it says he's using an equal number of black and white tiles to finish off the edges. So if he's got 35 tiles around those edges, he's going to need another 10 there and another 10 there. So he's going to do 35 plus 35, which is 70 tiles. So if he's now going to do half of them in black and half of them are white, that means he's going to have 35 black tiles, 35 white tiles, and the 4 tiles in the corner. So he's got 35 black tiles, and they are $7 each. 35 white tiles, which are $10 each. And he's got 4 corner tiles, which is $15 each. I'm going to do 35 times 7. I'm going to add to that 35 times 10. And I'm going to add to that 4 times 15, which is going to give me a total price. So, question 29. Which of these equations represents the line on that graph? If we use y equals mx plus c, first things first, I know that because the line is slanting down, the gradient is going to be minus. So it's going to be y equals minus some value of x. We know that the value it crosses on the y-axis is this c value here, so I know that's going to be plus 15. All right, find the equation that represents the graph. So first things first, the value in front of the x has to be a negative. It can't be that, and it can't be that. Because they're trying to trick us, we've got y is equal to, they've swapped these numbers around to make it 15 minus some value of x. This value here is the gradient of the line, and if we remember how to find the gradient, it is rise divided by run. So that's 15 high over 7.5. So my gradient is 15 divided by 7.5, which is 2. So that's minus 2. So 15 minus 2x, which gives me that value there. In the diagram, AB is a straight line. So what they're saying is, remember, when we use 2 letters, we're talking about this straight line here. What is the size of the angle marked X? Ooh, love these questions. All right, so what do we know? We know that angles in the triangle add up to 180 degrees. First things first, I see here is an isosceles triangle. So I know that this angle here and this angle here are going to be the same size. Now, because this is 90 degrees here, I know that this angle here is going to be 45 degrees, and this angle here is also going to be 45 degrees. Now, why is that important to me? Because I'm going to try and work out what the angles are in this triangle here. So now, looking at that triangle, I've got this angle here as x, I've got this angle here as 45 degrees. So I need to find this angle here. So let's rub out my construction lines. I need to find this little angle here. How am I going to do that? Angle here. How am I going to do that? I know that this angle here is 45 degrees. Why? Because this line is cutting my square in half. I know that this angle here is a right angle, so that's 45 degrees. Now, why is this important to me? Because what I'm trying to do is I know that angles on a straight line add up to 180 degrees. So all of these angles here add up to 180 degrees. And so I know that's 45 because this here is an isosceles triangle. That angle there is 60 degrees. And so I can find this angle here on that line. So that's going to be 180 minus 60 minus 45. 180 minus 60 minus 45 gives me 75 degrees. So I know that that angle there is 75 degrees. Now, why is that important to me? Let's get rid of all the rubbish again. Because I know that this total angle in this corner is 90 degrees. I know this little bit here is 75. And if I add on that bit there, it must make 90. So if I do 90 minus 75, it gives me 15 degrees. That tells me that angle there is 15 degrees. So knowing that this is 15 and that is 45, the total angle there would be 45, 55, 60 degrees. And of course, angles in a triangle add up to 180 degrees. So if I take them away, it's going to give me 120 degrees. Last 2 questions. The product of 3 different whole numbers is 60. What is the largest possible sum of these 3 numbers? Well, the product of 3 different whole numbers is 60. So they're looking for 3 numbers that when multiplied together give you 60. What is the largest possible sum of these 3 numbers? So we've got 15. So if we look at all the different ways we can make 60, that's going to be interesting. So moving on to question 31, the product of 3 different whole numbers is 60. What's the largest possible sum of the 3 numbers? Right, so we're looking for 3 numbers that multiply to give 60, not the largest possible. Now we could do all sorts of things. We could do, I don't know, 2 3 and 10, for example. But when we add those together, that only gives us 15. What about 15 and what does that give you? 4 and 1. That would give me 20. So yeah, no good. Basically, long story short, the answer to this question revolves around the fact that we know that probably the largest divisor that goes into there is 30 times by 2. And because we want 3 numbers that are all different, we can split that into 30 times 2 times 1. And when we add those together, we actually get 33. Now again, with that question, the best I can come up with is trial and error. This shape was formed by removing a sector from a circle of radius 9. Awesome. The area of the sector was 1/6 of the area of the circle. What is the perimeter of the shape to the nearest centimetre? The area of the sector was 1/6 of the area of the circle. Okay. So, what do? We know the area of a circle is given by pi r squared, which is pi times 9 squared, which is 81 pi. All right, that's the whole circle. Is that going to help me in any way, shape or form? Let's see what else we can do. Circumference of that whole circle is 2 times pi times radius, which is 2 times pi times, what would that be? 9, which is 18 pi. Okay, so the area of the sector was 1/6 of the area of the circle. Okay. So if we know that the area of this was 1/6, then we know that the part of the circle that's gone missing is 1/6 of the whole circle. So what we now know is we are looking for 5/6 of the circumference of the whole circle. That will give me this area, or that length there, because remember we're looking at perimeter, so we're looking at length. So we are looking for 5/6 of the circumference, which is 18 pi, and we're going to add on to that. Now bearing in mind all that's done is giving me the yellow highlighted section, this length here and this length here, which will be plus 18. All right, so 6 goes into 18 3 times. 5 times 3 is 15 pi plus 18. So firing up my trusty calculator, I get, what do I get? 15 times by, we'll hit the pi button. And I go, no, you guys can't see this, but I'm just talking through it. Plus 18. And we'll get that as 65. So my calculator gave me 65.123, blah, blah, blah. Because it wants it to the nearest centimetre, I'm going to say 65 centimetres. And bearing in mind that looks like nothing like 65, let's actually make it like 65. And as it says, that's the end of this test. Thank you very much. Hopefully the answers are, actually, there was one thing I was going to do. I'm actually going to go back to question number 7, if I remember rightly. Sorry about the quick zoom. I've checked on the answers, and actually it turns out that they believe that you can get 5 of these squares horizontally. So 5, 5 and 5, which means that that isn't correct. And we'd be looking for our nearest answer to 125, which in that situation would give you the 200. So what I'm going to do is delete that answer there. And then I believe that was all I was going to check. All right, thanks very much, guys. More coming soon. Hopefully you're enjoying the video and others' videos on mathsguru.com. Speak to you soon. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.